Hello dear students, I welcome you all to my channel. Let's continue with the very interesting topic for the day, and the name of the topic is bisectors of angles between the lines. Now what is the meaning of this? Let's try to understand using the diagram. Suppose let me take two lines out here. Okay, so there are two lines intersecting each other. Okay, so this is my line 1 and let me call this as line 2. Okay, so this is my line 1 and let me call this as line 2. Okay, so there are two lines being intersected out here. So whenever they get intersected, what happens? Angle will be formed, right? For example, you see that this is one of the angle. Yes, and there will be one more angle, and that angle is this angle, isn't it? Yes. Okay, so now I'm going to introduce one more line. Okay, and that line will be bisecting this angle formed. So you remember how much ever is this angle, this will also be the same as they are vertically opposite, and how much ever is this, the value of this will also be the same. So basically I want to find what is the bisector of this line. So let me draw a rough diagram for the bisector. So for example, this can be my bisector. Okay, so this is one of the bisector of the angle. Okay, but there will be one more angle possible, that is this line, isn't it? So if I bisect this angle, then this will also be the bisector of angle. Yes, so basically when there are two lines intersected, L1 and L2, there will be two angles formed. So if you want to bisect those angles, there will be two bisectors available. Okay, so let me call this as bisector 1 and let me call this as bisector 2. Okay, fine. So that's what is given out here. So the equations of the bisector of the angles between the lines, so basically the lines L1 and L2 are these two. All right, so these two are the given lines which are getting intersected. Okay, now the equation of bisectors, since there are two equations, two bisectors, the two equations will be given by this particular formula. If you take only plus, you'll get one equation. If you take minus, you'll get another equation. All right, so these are the equations of the bisector of angle between two given lines. Okay, now from this you have to come across two very important remarks. Okay, so the first one is to distinguish between the bisectors of acute and obtuse angle. See, we are going to do the sums based on the same thing. Okay, but here only I'll explain you how to distinguish between the bisectors of acute angle and obtuse angle. Now let's try to understand what is the meaning of this. For example, if you see here, this angle looks less than 90 degree. So can I call it acute angle? Yes. So basically, if you see in the diagram, B2 is the bisector of acute angle, isn't it? Yes. Okay. Now similarly, if you see here, this angle is greater than 90. So that's why this becomes your obtuse angle, and B1 is acting like your bisector of obtuse angle. So basically from this remark, what we are going to do is we want to identify whether B1 is bisector of obtuse angle or acute angle. Similarly, we will try to see whether B2 is bisector of acute angle or obtuse angle. Okay, so that's what is our aim in this case. Okay, so before we do that, let us try to see what are the values of tan in between 0 to 90 degree. All right, so fine. So for example, we have tan 0 degree is how much? Tan 0 is 0, right? So similarly, tan 30 degree is how much? It is 1 by root 3. Yes, so we have tan 45 degree is 1, tan 60 degree is root 3, and tan 90 degree is undefined, or let me call this as infinity. Okay, so pay attention here carefully. So what you're going to do is, see here, you will be able to find the equation. For example, let me consider this. All right, so for example, let me consider this line and this line. After finding, see, first what you need to do is you have to find both the bisectors, and after that you want to verify which one is bisector of acute and which one is bisector of obtuse. Okay, for example, let me take this line and this line. Okay, so we'll find what is the angle of intersection between them, that is, we'll find this angle. Okay, now if this turns out to be for example greater than 45, for example, if this angle turns out to be greater than 45, then this angle will also be greater than 45. All right, because this B2 is the bisector of this angle, isn't it? So how much ever is this angle, same will be this angle as well. If this is, for example, 50 degree, for example, if this is 50 degree, then this will also be 50 degree, isn't it? So altogether, how much is this total angle? This is 100, which is greater than 90 degrees. So that's why this becomes your obtuse angle, isn't it? So if this angle, okay, that is the angle between a line and the bisector, turns out to be less than 45, for example 40 degree, then this is also 40 degree, so altogether it is 80. So that means if this is 80, this becomes your acute angle. That means if this is your acute angle, then B2 is the bisector of acute angle, isn't it? Okay, so we have understood how to identify, right? So basically we have to find the angle between the line and the bisector. Okay, take any line and take any bisector and find what is the angle between them. Okay, so that only tells you whether the bisector is bisector of acute angle or obtuse angle. Okay, so basically, see, in order to find this angle, that's the angle of intersection, we make use of a very famous formula, that is tan theta equals to m1 minus m2 whole divided by 1 plus m1 m2, isn't it? Now you keep calculating this. Okay, so you see that this is 0 and this is less than 1, isn't it? 1 by root 3, remember 1 is smaller compared to root 3, so this fraction is also less than 1. This is less than 1, this is less than 1. Okay, so basically till 45 degree, the value of tan will always be less than 1. All right, so basically if you keep on calculating this and if you get that this is less than 1, then this means that this theta, this angle, is less than 45 degree. Okay, now if this, see here, from here onwards we have, as the value of theta increases, that means after 45 we have 60 degree, yes, and after 60 we have 90 degree, so all these values are greater than 1. Okay, so that means when you evaluate this and if this turns out to be greater than 1, that means this theta must be greater than 45 degree. Okay, and if the angle of intersection is greater than 45 degree, then this bisector is the bisector of obtuse angle, because this angle becomes greater than 45 degree. All right, so if the question is asking find the bisector of acute angle, then what you need to do, you need to find the angle of intersection using this formula, and if this turns out to be less than 1, then the angle or the bisector will be the bisector of acute angle. Hope the thing is clear to you. So our aim is to use this formula, tan theta equals to this formula, and if this is less than 1, then bisector is acute bisector. Okay, and if this is greater than 1, then bisector is obtuse bisector. All right, so that's what we need to understand from this. Okay, so let me erase this. So the next remark that we need to understand is number 2, that is bisector, to find the bisector of the angle containing origin. Okay, so there will be a direct question given to you, so your direct formula will be this one. So there will be only one, there is no plus minus, but remember one thing that you need to remember is C1 and C2, that is these two must be positive. If they are given to be negative, you have to make it positive. All right. So after making positive, this gives you the bisector of the angle containing origin. All right. So you may pause the video to note down the formula. All right, so let me take the first question. So question says, find the equations of the bisectors of the angles between the lines. So there are two lines given to you, right? So let me write down what are the lines given to you. The given lines are, so one is 3x minus 4y plus 7 equals to 0. Let me call this as equation 1. And other one is 12x minus 5y plus minus 8 equals to 0. Let me call this as equation 2. And remember, this is exercise 11.11. Okay, so exercise 11.11. Fine. So we need to find what is the equation of bisectors and bisector of angles here. All right. So here use direct formula out here. So this is your A1, B1, C1, A2, B2, and C2. Okay. So therefore, equation of the bisectors of angles are, okay, so we have a1x, so same thing we have to write a1x plus b1y plus c1 equals to c1, right? That is 3x minus 4y plus 7 whole divided by this a1, b1 and c1. So under square root we have to write a1 square, that is 3 square, plus b1 square, that is minus 4 square. Okay, we have plus minus out here. Again we have to write the second equation, that is 12x minus 5y minus 8 whole divided by, so this becomes my a2, this becomes my b2, so a2 square plus b2 square, right? Okay, let's simplify this now. So we have 3x minus 4y plus 7 whole divided by, so this is your 3 square is 9 plus this becomes your 16, which is square root of 25. And what is square root of 25? It is 5. So we have plus minus 12x minus 5y minus 8 whole divided by, so 12 square is 144 and 25, right? So 144 plus 25 is 169 and square root of 169 is 13. All right. So we have, let's do the cross multiplication. So we have 13 into 3. Okay, so 3 3s are 9, 3 1s are 3 into x is there minus, okay, so 4 into 13 is 52 y plus 7 into 3 is 21 carried over 2, so 7 into 1 is 7 plus 2 is 91. All right, so we have plus minus, okay, so 5 into 12 is 60x minus 5 into 5 is 25 y minus 5 into 8 is 40. Okay, now before opening the bracket, now we'll split the equation. Okay, so that is, from here two equations will arrive. See, one is 39x minus 52y plus 91 equals to, okay, so let me take only plus. Okay, so there are plus and minus, so if I take only plus, then we have 60x, right? Okay, 60x minus 25y minus 40. And what is the other equation? So we have, this will remain as it is, so 39x minus 52y plus 91 equals to, now take the negative one. So if you take negative, all the sign will become opposite. Yes, so we have minus 60x plus 25y plus 40, right? So this means, okay, so let me get everything out here. So we have, so 39 minus 60. All right, so 39 minus 60, let's subtract. So bigger one is 60, so 60 minus 39 becomes, so 10 minus 9 is 1 carried over, Okay, so we don't have carried over, so we have got 5 here. 5 minus 3 is 2, so 21x. But since this becomes greater and its sign is negative, so that's why this is minus 21x. Similarly, this comes over here, so becomes plus, right? So this is minus, this is plus, so again we need to subtract. So 12 minus 5, okay, so sign is again going to be negative. So 12 minus 5 is going to be 7, so we have got y. So here we have got 4, 4 minus, this is 2. Okay, so this is minus, comes over here, becomes plus. So 91 plus 40. So 1 plus, this is, okay, so sign is going to be plus. So 1 plus 0 is 1. 9 plus, this is 131 equals to 0. Yes. And what is the other equation? See, other equation is this one. So 39, this comes over here, minus and becomes plus. So 39 plus 60 is 99x. So this is minus, this comes over here, again becomes minus. So minus and minus both will get added, but the sign will remain minus itself. So 5 plus 2 is 7, 2 plus 5 is 7, so 77y. So this comes over here, becomes minus, so 91 minus 40. So 91 minus 40 is your 51 equals to 0, right? So these are the two required equations, and if you want to make this positive, or if you want to multiply both sides by minus, that's also fine. So basically these two gives me answer for this particular question. So pause the video to note down. Now let me take question number 2. I'll take only sub number 1. So question says, find the bisector of angle between the following pair of line in which the origin lies. Okay, so this falls in the remarks number 2. So that's why let me take the equations. So the given equations are, so 2 1, the given lines are, okay, so the first one is 12x minus 5y plus 3 equals to 0. Now in such kind of questions, as I said earlier, C1 and C2 must be positive. Now what's the value of C1 here? It is 3. So that's why this is fine for me. So let me call this as equation 1. Okay, and what is the other line? The other line given to us is 4x plus 3y minus 2 equals to 0, right? So this is another line given to us, and let us see what is the constant term out here. So c is minus 2 out here, but we have to make it positive. So let's multiply this by minus. So if I multiply with minus, then I'll get minus 4x minus 3y plus 2 equals to 0, right? So let me call this as equation 2. Let me repeat once again, both C1 and C2 must be positive in this case. Okay, so therefore the equation of bisector of angle containing origin, okay, containing origin is, okay, so we have this, right, that is a1x plus b1y plus c1 whole divided by square root of a1 square, that is 12 square, plus b1 square, that is minus 5 square, equals to, now we have got only one sign, that has to be plus, okay, and a1 a2x plus b2y plus c2, and what is that? This is equals to equation 2, right? So we have minus 4x minus 3y plus 2 whole divided by, okay, so what is a2? a2 is minus 4 square plus what is b2? b2 is minus 3 square. Now let's evaluate the equation. So from here we get 12x minus 5y plus 3 by, how much is this? This is going to be 13, isn't it? Equals to, and how much is this going to be? This is going to be 5. So we have minus 4x plus, I'm sorry, minus 3y plus 2 whole divided by, how much is this? This is 5. Okay, so let's do the cross multiplication. So 5 into 12. Okay, so let's multiply this and 5. So we have 60x minus 25y plus 15 equals to now 13 into this whole thing. So we have minus 52x minus 39y plus 13 into 2 is 26. Let me get everything out here. So we have 60, this comes here and becomes plus, so 60 plus 52 becomes 112 x minus 25, and this comes over there becomes plus, right? So this is bigger, so 39 minus 25 becomes your 14, sign will be plus, this comes over here becomes minus, so minus 26 plus 15 is minus 11 equals to 0. So this is the required equation or the bisector of angle containing origin. So pause the video to note down. Now let's take question number 3 So let me write, the given lines are, okay, so these are the two given lines, and as per the question we need to find the bisector of acute angle between the following pairs of lines. So they are asking the bisector of acute angle, that means the angle of intersection between any line which you choose, and the bisector must be less than 45 degree, or tan theta must be less than 1, isn't it? So that's what we need to find in this case. Okay, so this is my line 1, so let me write as L1 and let me write this as L2. Okay, so equation of the bisectors of angle between L1 and L2 are, so equation will be given by, equation of bisector will be 3x plus 4y minus 11 whole divided by square root of 3 square plus 4 square equals to plus minus, so equation of bisectors, remember, so we have another is 12x minus 5y minus 2 whole divided by 12 square plus minus 5 square. Now let's simplify this and find what are the bisectors out here. Okay, so I have found the equation of bisectors. Okay, so this is my B1 and this is my B2. Now let me choose any two. Okay, any two lines, and among those two lines, one of the line has to be L1 or L2, and other line has to be the bisector. Okay, so let me choose L1 and B1. Okay, so the angle between L1 and B1 is given by, okay, so I'm choosing L1 and B1. Okay, so first let me find what is the slope. Okay, so I need the slope, right? So let me find what is the slope. So slope of L1, so let me call this as M1. So this is my L1, so slope is given by minus a by b, that is minus 3 by 4. Similarly, slope of B1, so slope of B1 is, let me call this as M2, it is given by minus a by b. A is minus 21, b is 77. Yes, so we can cancel with 7, so 7 3s are 21, 11, so this is 3 by 11. Okay, so therefore angle between L1 and B1 is given by tan theta. So formula says M1 minus M2, M1 is minus 3 by 4 minus M2, M2 is 3 by 11 whole divided by 1 plus M1, M1 is minus 3 by 4 into M2, that is 3 by 11. Alright, so let's quickly evaluate this. So I said if this full thing turns out to be less than 1, then the angle between L1 and B1 is less than 45 degree. Okay, but if this turns out to be greater than 1, then the angle between them is greater than 45 degree. Okay, so let's see how much do we get. Okay, so after evaluation I see that this tan theta turns out to be 35 by 45. If you want to cancel, that's also okay, but I find that this is greater than 1. Remember, if your numerator is greater than 1 or greater than denominator, then the fraction is greater than 1. Okay, so as numerator is greater than denominator, so that's why this whole fraction will be greater than 1. So that means the angle between L1 and B1 is greater than 45. That means, okay, so let me show you using diagram out here. So for example, suppose this is my L1 and this is my B1. I'm sorry, L2. All right. So let me draw B1 and B2 as well. So this is my B1 and this is my B2. All right. Now I have chosen what? I have chosen L1 and B1. Right. So I have chosen L1 and B1. So this is my L1, this line, and this is my B1. And I found it that this angle, the angle between these two is what? It is greater than 45 degree. So if this is my greater than 45 degree, then this B1 is the bisector of what? Obtuse angle. So that means if B1 is the bisector of obtuse angle, then obviously this B2 must be bisector of, see, B1 is bisector of obtuse angle. That means this angle is what? Obtuse angle, isn't it? Now obviously if this is obtuse angle, then this has to be what? This has to be acute angle, isn't it? Because obtuse and this, if I add them, I will get 180 degree, right? So obviously this has to be acute angle, and the other line, that is B2, has to be the bisector of acute angle in this case. All right. So therefore, so at last you will write, therefore B2 is the bisector of acute angle. Okay, acute angle. And what is B2? That is, you'll write, what is B2? B2 is this one. So 99x plus 27y minus 153 is the bisector of acute angle. Okay, so that's what you need to write at the end. So pause the video to note down. Okay, let me read question number 4. So in this case, you have to find the bisector of the obtuse angle between the lines, these two. Okay, so I have already done the solution part because this is going to be a quite confusing one. So in order to explain you properly, I have already written down the solution. So let me explain you now. So you have to find the angle between one of the line, that is L1, and one of the bisector, that is B1. And if the angle turns out to be, or if the value of tan theta turns out to be greater than 1, then the angle or the bisector B1 is the bisector of obtuse angle. But if tan theta turns out to be less than 1, then that B1 is the bisector of acute angle. Okay, now let me begin. So let me write the given lines to be L1 and L2. Okay, the equation of bisectors, see here carefully. So this is my a1x plus b1y plus c1 equals to 0. So this by equals to plus minus this one, right? Okay, so there's no confusion out here. So this is how much? This is root 5 and this is root 10. Now this root 10 can be written as root 5 into root 2. Why am I doing that? Because I want to cancel root 5 also. So root 5 and root 5 get cancelled here. Okay, so now let's do the cross multiplication. So root 2 into this becomes 2 root 2x plus root 2y minus 4 root 2. Okay, equals to, we don't have anything, that is we have got 1 out here, so 1 into anything becomes that much itself. Okay, so we have got plus minus as well. Now let me split it. So I have written only plus here and I have written only minus out here. Okay, so there are two bisectors as you can see out here. So let me get everything out here. So this becomes, this comes over here, becomes 2 root 2 minus 3, x is common. Yes, similarly you take y common and you will get this as one of the bisector, and let me call this as bisector B1. Okay, so please verify by yourself. Similarly from the second one, that is this one, you arrive at this bisector and let me call this as B2. Now we will always choose L1 and B1. There is no problem with that. Okay, fine. So we'll find what is the slope of L1. So slope of L1 turns out to be minus 2 using minus a by b form, and slope of L2, I'm sorry, B1, that is this one, is given by minus a by b. Now a is this one, remember. Okay, so a by b is this much. So this is your b. Okay, so in this case you have to use calculator. Okay, remember that. So we have tan theta equals to, so m1 minus m2. See here carefully, this is m1 minus m2 whole divided by 1 plus m1 m2. Okay, so let's see the simplification part here. So minus into minus becomes plus. All right, so we have minus 2 into this. Okay, so minus 2 into this becomes this much, isn't it? So minus into minus becomes plus, so that's why I've written plus. So we have 2 root 2 minus 3 whole divided by this. So basically this is your LCM. Okay, here we have got divided by 1. The LCM of this and this will be this much. So 1 divide this by this, you'll get this much itself. So this into minus 2 will be this much. Okay, so divide this by this, you'll get 1. So 1 into this becomes this much itself. And how this plus arrived? Because of minus into minus. Okay, fine. Now in the denominator also we have got the same thing, right? So minus into minus becomes plus. So we have, yes, so one, the LCM of 1 and this much is this much itself. So divide this by 1, so you'll get this much. So this into 1 is this much. Yes, okay, so we have this minus and minus gets nullified, so only plus is there, so I have written plus here. So 2 into, see here, this divided by this is 1 itself, so we have 2 into this whole thing, which is this much. Okay, now let's simplify this. We see that this and this gets cancelled. All right, so we have 2 root 2 and 2 root 2, they get cancelled, so we have 2 minus 3 is minus 1. Okay, so we have here root 2 plus 4 root 2 is 5 root 2, minus 1 minus 6 is minus 7. Now if you calculate, or if you use your calculator, this turns out to be 0.07. Okay, so we have in the numerator minus this, right, and in the denominator we have got this. Now if you see here carefully, numerator is again greater than the denominator, so what is the overall value? Overall value will be greater than 1 because of this modulus sign. That means the angle between L1 and B1 is greater than 45 degree. So that means B1 is the bisector of obtuse angle. Okay, so therefore our answer will be this one. Okay, because they are asking what is the bisector of obtuse angle. So therefore bisector of obtuse angle is, so you can write down the equation, which is 2 root 2 minus 3x plus root 2 minus 1y plus 5 minus 4 root 2 equals to 0. So pause the video to note down. Now let me take question number 6. I'm just going to give you a hint for this question. So question says, prove that each point on the line 2x plus 11y minus 5 equals to 0 is at equal distances from the line 2x. Okay, so let me write what are those two lines. So 24x plus 7y minus 20 equals to 0, and the other line is 4x minus 3y minus 2 equals to 0. Okay, and the given line here is 2x plus 11y minus 5 equals to 0. Now as per the question, what we need to prove is, we need to prove that this line, every point on this line are at equal distances to these two lines. Okay, now you might be thinking this happens if these lines are parallel. For example, we have done many sums on parallel lines. For example, if these are the two lines, this line is this and this line is this, then if this lies exactly in the midway, then what happens? Every point on this will be equidistant, isn't it? From here to here is also, if this is 10, from here to here will also be 10. Similarly, from here to here will be also 10, and from here to here will also be 10. But this is not the case out here. You know why? Because this line and this line, they are not parallel, because the slope of this and slope of this, they are different. Okay, so if they are not parallel, then they must be intersecting, isn't it? So we know that parallel lines does not intersect. So if they are not parallel, then they must intersect. Okay, now if this is my L1 and if this is my L2, okay, so this is my L1, L2. Now we have to prove that every point on this line lies at the same distance to these lines, and this happens only with the case of angle bisector. For example, if I take this as your angle bisector, then choose any point, for example this point. Okay, measure its distance means perpendicular distance. Okay, so this distance and this distance both will be same. Similarly, if you choose this point, from here also draw perpendicular distance, this distance and this distance both will be same. Okay, so basically what we need to prove here is this is one of the angle bisector of these two. Okay, so that's what you need to prove, and you will do the sum by yourself. Okay, so this is your question number 6. Okay, now let me take question number 7. Here also I am giving you the hint. So what here my hint is a triangle is formed by 3 lines. Okay, so a triangle is there. So let me draw the triangle for you. So triangle is formed using 3 lines, and let me write down the equations. So the equations are given to be 3x plus 4y equals to 10, but we need to write this in general form. So minus 10 equals to 0. Another line given to us is 4x minus 3y minus 5 equals to 0, and the last line is given to be 7x plus y plus 10 equals to 0. Okay, so these are the 3 lines given for a triangle. Find the internal bisector of the angle opposite to the side 7x plus y plus 10 equals to 0. So basically this is the side, and the angle opposite to this side is what? This angle, isn't it? So basically you need to find the internal bisector of this angle. That is the equation of this line, and it's very simple. See, if you extend this, okay, so there are 2 lines and we need to find bisector of the angle between this L1 and this L2. But when you find the equation of bisector, you'll get 2 bisectors. One is B1 and another will be B2. But we don't want B2. This is not internal bisector, isn't it? So we want internal bisector B1, and B1 is calculated using what? Okay, so this angle will always be acute angle. Remember that. All right. So you want to draw internal bisector for acute angle. So as I said, this will be your acute angle. So basically you need to find bisector of acute angle. So that will give you the internal bisector. Okay, so I have given you the hint. So this is your question number 7. So question number 6 and question number 7 you will try by yourself. Okay, so with this we close for the day. Thank you very much.